Before this video starts, just a quick note from Editing eMachine. This video was recorded almost 2 years ago at this point. That shouldn't affect the quality of the video, but I thought I should just clarify that before people get confused about the date in the bottom right corner of my screen. Other than that, thanks for watching, and I hope you enjoy. Hey guys, eMachine03 here. Welcome back to another math video. I had an idea to do this video a while ago, but I'm going to be completely honest, I forgot about it, and I also had school, and I kind of wanted to do that instead of making YouTube videos about math problems from anime. But now school is over, I'm on summer break for a little bit before I go back to college. And so I decided to make a video about this math problem that I found online. It's a lot more complicated than the last math problem I did. As you can see, it's a calculus 2 problem. So it'll be a little more complicated. I'm not going to explain how everything works because that would take a while, but I'll try to explain it the best I can for someone who already has knowledge of calculus 2 concepts. So I don't know what the story is. I just assume they're in class in My Hero Academia, and then this problem pops up. I've never seen the show before, I'll be entirely honest, but I think that's all you really need to know. So once again, this problem is like too hard for me to figure out on my own. Both because I didn't learn about some of the concepts needed to solve this, but also it's just kind of hard. So I used the Reddit solution to figure this out, and you can find the solution in the description of this video as always. So yeah, let's get on to the problem. So as you can see, I've rewritten the problem more sloppily, but it's the same thing. And you may have noticed it says log on the actual problem, and I rewrote it as ln. I don't really know how you'd do the problem if it was log. So, and the guy on Reddit just said it's ln, and usually when you see log, that means ln. So we're just going to say it's ln. And then here are some givens, or as the guy on Reddit said, definitions that we're going to need to solve this problem. And these are pretty much all going to be used at random points throughout the solution. And so the first part of the solution that's important is you look at this problem and you're like, I have no idea how to deal with those e to the x's over here, like over in the numerators. But then you look over here and realize, oh, e to the x minus e to the negative e to the x over 2, that's just sine h. Now, sine h, that's hyperbolic sine, and cosine h is hyperbolic cosine. I'm not entirely sure what those are, but I know that from what I know, they're pretty much sine and cosine, except they're a little different. You can see over here, the derivative of sine of h is cosine of h, which that's normal. But this is different. The derivative of cosine h is sine of h, which usually, with normal sine, normal cosine, the derivative of that would be negative sine. So I guess that's a little nice. And then over down here, you also have this identity that's going to be important eventually. So the first thing we're going to do to solve this problem is just rewrite some of the stuff to make it easier to read. Now, probably what you're thinking here is, what is this? Yeah, it does look pretty stupid, but you're just going to have to look at this thing right here and see, okay, natural log of 1 plus the square root of 2. Well, natural log of x plus the square root of x squared plus 1, that looks kind of similar. And that makes you wonder, what value can you put in for x where when you have some value plugged in for x and arcsine of h, you get natural log of 1 plus square root of 2. Well, if x equals 1, you would have natural log of 1 plus the square root of 1 squared plus 1, which is 2. So, yeah, that means this equals arcsine h, arcsine h of 1. So, yeah, we can rewrite that as well. And this is not u sub. We're just rewriting stuff to make it kind of easier to solve. So we've got that. And then now we need to do u sub. In this situation, we could do sine or cosine. But if you realize something, remember when you're doing definite integrals, you need to change these limits of integration to fit with the u sub. Because you have to change the limits of integration, you need to think about which u sub would be easier to change the limits of integration. Well, if you substitute u equals sine h of x, well then that'll be easy, because if you plug arc sine of 1 into sine of h, that would just be 1. So that's going to be easier to do. So remember, you have u equals sine h. You got to find du equals cosine h of x dx, the differential thing. So we've got to rewrite both of the limits of integration, and so we'll do that over here. So that means we can rewrite the limits of integration, but first we're going to have to rewrite the equation so we can actually do the u sub, because when you do u sub, you have to have the du so that you can actually do the substitution. So we will just rewrite the same limits of integration. We'll get to that later, don't worry. So we're just splitting it up, but the reason we split it up is that obviously that is du, as you can see over there. So we do have a du, so we can do the u sub, and then now that's we're gonna put those different limits of integration in. Now, if you've done calculus, you might be looking at this and you're like, oh, that sucks. We have u's and x's, and yeah, that's pretty bad. Normally you wouldn't be able to do anything here, but that's where this equation comes in. We can solve for cos h to the 10th power in terms of hyperbolic sine. And then we can raise both sides to the 5th power. So that will give us cosine h 10 of x equals 1 plus, oh, and remember, sine of h is u over here. So we can rewrite it as 1 plus u squared to the 5th. And then would you look at that? Now we have it in terms of, okay, so we have the integral 0 to 1 of u cubed times 1 plus u squared to the 5th du. And this is a polynomial, so all we need to do is just expand it out, and then the polynomial integral is really easy, remember. So this is going to take a while, obviously, because it's like a 5th degree. I could use Pascal's triangle, but to be honest, I don't really know how that works, so I'm just going to expand it out, and I'll try and do a time lapse, so you'll get to watch me suffer. Let's go. Okay, so we've finally done all that distributing. You can see it was a mess. I don't know if I've ever distributed something as annoying as that, but somehow I didn't mess up. So then that means we can find the antiderivative. And then this is actually pretty freaking easy, hopefully. So now we have to use the fundamental theorem of calculus, and I'll just write out if you somehow don't know this and are still watching. And so this is A and this is B. But as you can see, A is 0, and if you plugged in 0 in any of these terms, they would become 0. So we only need to plug in B. We don't have to do the subtraction part. So then we're left with and then let's see, can I open them up like freaking Desmos or something? Let's see. Get Desmos up on my other monitor. Okay, so we are here on Desmos. Let's get our math problem open. I refuse to do this without a calculator. I'm gonna put this on my other monitor. I'll type it out that way. As you can see, the answer is 107 over 28. There we go. that is the answer to this question. And we can go back and check the Reddit page to actually see. God, I hate this so much. This meme is literally from 2012. What are you guys doing over at Reddit headquarters? Like, I do not understand how they think this joke is still freaking funny. But whatever, as we can see, the answer is 107 over 28, which is what we got, and that's correct. And if we check this panel from the manga, you can see whoever this is, she answered it correctly. He didn't. I know that's Deku. I have no idea who this person is, but she got it correct. That's impressive. I have no idea how you would solve this problem within the span of a few minutes, especially. I think they're like middle schoolers in the show. I have no idea how a middle schooler would solve this problem. But anyway, regardless, we have solved the problem using the work of this guy on Reddit from 4 years ago. And yeah, that's about it. I hope you learned some stuff about calculus. It's kind of weird, but honestly, I think this stuff's it's quite interesting, honestly. You know, just like all this manipulation you can do. I feel like calculus really like ties together algebra. I feel like in algebra, you just like do problems for no reason, but like in calculus, you actually like apply all of your skills to figure out this crazy stuff. Yeah. So yeah, I mean, math can be pretty fun. It doesn't have to be useful in the real world at all, but it can just be fun in and of itself. And I mean, that's why I do these videos, because I have fun making them. Anyway, I hope you enjoyed watching this video, and as always, I'm eMachine003, and I will see you guys later.